Today we will discuss a new type of file organization in the second unit of database management system. So already we have learned sequential file organization as well as index sequential file organization. So in both type of file organization we are searching different records either sequentially or by using index mechanism. We can search also by using index mechanism also we can able to retrieve the records or accessing the records we are using. So in both of them directly we are not able to access records from database system. So how we can directly access that particular record and directly we can store, directly we can insert. So access operation, accessing, inserting, deleting and updating all the records that can be this type of operation can be done directly in case of direct file organization. So today's topic will be direct file organization. Direct file organization. So in this type of file organization we can access directly, means very fast. In case of sequential it's a time taking or conversion process for large amount of records whenever stored. In case of index sequential the complexity also increased. There's index mechanism is added to the sequential file organization. Both sequential concept is also there. So it is some extent time taking or not so fast as compared to direct file organization. So now we'll discuss how directly we are accessing records from database system. Also we can able to directly store in both the sequential file organization or serial or index sequential file organization. The access media is not direct. So we can insert according to a particular sequence in a particular order, P order. But in case of direct file organization, directly we can store records in the memory and directly we can manipulate, directly we can access, directly we can update. So very fast, in a very fast response time we can use this direct file organization. Okay. So it refers to an effective way to organize data where there is a need to access individual records directly. Suppose a particular record is required, so directly that particular record can be accessed in a very fast instant. Just like your iPod, you are listening the song from iPod. In the iPod song number 111, directly you cannot play. Okay. In case of a cassette, what happens? Serially, one by one it will be played. Okay. But in case of iPod, the hard disk, directly you can access, directly you can play that particular song. So for that it requires a reference number that we will discuss. So direct file organization allows data to be retrieved quickly. It allows data retrieve very quickly. Very quickly we can retrieve data from this type of organization in a random manner. Another concept is in a random manner. So randomly you can store different records. Randomly you can access different records from database. Okay, randomly we can this random processing, random concept is added to this file organization. So randomly you can able to store, you can able to insert records in database, and randomly also we can able to access records from database. Okay, so this random, that means it does not manner how data are stored. We can operate randomly, but that does not matter how data are stored. That is not matter. In any way you can store. Okay, so in this method, the unique key that is used to organize files in a converted directly to a memory address. So here directly to a memory address. So a key field is required. Okay, a key value is required. That key value helps to locate the memory address for that particular key, that particular record that is associated with that particular key is located. So instantly we can access, instantly we can fetch that data. Okay, so from storage device or memory, that memory address can be directly retrieved by the help of a key value, and also we are using a mathematical function. Okay, so that's a hash function. Okay, so hash function is used. A hash function is used in case of direct file organization. What does this hash function? What does this hash function do? What is the important functions of this hash function? So this hash function locates direct memory address a particular record. So for this hash function, it is a mathematical function. It requires a key value. Okay, a key value, and it generates a memory address from the memory block, so that directly we can fetch that particular record. Okay, so this is a hash function, that is h. We can denote this hash function is denoted as h. It is a mathematical function. It is a mathematical function. Okay, it is a mathematical function. So this hash function provides the memory address. Okay, this hash function provides the memory address by accepting a key value. So this hash function accepts a key value, and it provides a address, memory address. Okay, so how this hash function is accepting, that we will discuss. So it is this hash function is a mathematical or arithmetical manipulation process. Okay, it is a arithmetical manipulation process. This hash function, this process is also called as a mapping function. It is a mapping function. It is a mapping function. It is a mapping function. So mapping means a mapping between a key value to address, memory address. A key value, suppose we are searching a particular record, the record must have a key. That key value is linked, is related with a memory address. So this hash function does this type of work. It accepts a key value, it provides a binary address or memory address, so that directly we can able to store, directly we can able to access, directly we can able to update. So all operations can be done directly or randomly. Okay, so this is mapping from key value to an address value. So this mapping function, the mapping between this hash function is a mapping function. This is mapping between a key value to address value. Okay, key value, or you can call record key value to the address, memory address. So it provides direct the address of that particular record. Okay, but before before operation of this hash function, or before going to find the address value by using a hash function, first we have to provide the record key value. This value is required. Suppose we are using a employee code. So from employee code may be the record key value. So from employee code, directly we can access all the information regarding that particular employee. So on the record key, the employee code is related with that particular address. Suppose a record key value, suppose the employee code G001. Okay, so G001 is a direct link with the binary address, binary address. So this hash function accepts this value and it converts the binary address. So whenever accessing that particular record, suppose G001, so directly it can point out the binary address or memory address. So that directly we can access. Okay, so this hash function provides the binary address, binary or a numerical address of the each key value. So that this hash function, due to this hash function, we can randomly access different records from database. Suppose this is the hash function. Suppose this is the hash function. Okay, this is the hash function. We can call it as H. Okay, so it requires a record key value. Record key value. It requires a record key value. This key value is the hash key or a hash column. This record key value is the hash key or hash column. Okay, and this hash function is a mathematical function. Okay, it is a mathematical function, and it provides a address, memory address. It provides a address. This address is the numerical binary address. This is the binary address. It is the binary address of the memory block. Binary address of the memory block. Okay, so this hash function is generated on the key column, so that this key is called a hash key or hash. Okay, so for a hash function, it requires a hash key or record key value or a hash column. By manipulating this value, it provides a address. This address is the binary address. Okay, so directly we can fetch that particular address, so that we can insert that position, we can insert in that location, or we can retrieve records from that location, or we can update records from that location. Okay, so in this way, this is hash function is working. Okay, now we will find an example. Suppose let's consider a hash function H. Now consider hash function H. Let us consider a hash function H. Okay, and K be the record key value. Suppose K be the record key value, so hash function H of K. Here K is the record key value, the key value. Let H be the hash function and K is the key value. So this function is H of K. Okay, the value of the H of K is used as an address. And for our application, we regard that the value be in same range. Suppose we are having a memory space, large memory space, and each memory space must have identified by a address, just like a world we have partitioned several continent, several countries, state, block, district, all this like that. Similarly, entire block, entire memory block, entire memory space is divided into different memory blocks. Suppose each block has a binary address. Suppose the address range, suppose like S1 between S1 and S2. What is S1? S1 be the lower limit of the, it is address. S1 is the address, binary address at the lower limit. So it's a minimum. So S2 be the upper limit. Suppose it is the upper limit. So this is the memory space. This is the first. In this way we are moving, and this is the last. So this will be the S1 and this will be the S2. So all binary addresses lies between S1 and S2. Okay, all binary addresses lies between S1 and S2. So here h of k provides this address. H of k provides address. That address must be lies between S1 and S2, not beyond the S1, not beyond the S2. Means within this limit S1 and S2, all binary addresses will be generated by this hash function. Okay. So the requirement of hash function h of k, it provides a value. So we are providing h of k. This hash function provides the values, the address values or binary address. These addresses must lies between S1 and S2. Okay, so that we can directly fetch that particular record. Okay, so entire memory block of the computer is divided into several blocks, and where it is permitted to store in this area. Suppose this area is partitioned and several addresses, just like our continent state block like this. So this hash function h of k is the record key value. We are providing a record key value. This value is accepted by the hash function, and this hash function provides a binary address. This address must lies between S1 and S2. So any addresses between S1 and S2 that can be directly generated by this hash function by providing a record key value, that is your k. So k value you have to provide. Okay, so the address will be generated by this hash function. That addresses must lies between S1 and S2. This is the condition. Okay, so this hash function can be any simple or complex mathematical function. Okay, the hash function is also applied on some columns or attributes, either key or non-key column. This is hash key, this is key, this is values. It may be a key or any non-key attribute from the table. That is also accepted. But it provides a address. Okay, that will be manipulated by the hash function. Okay, so each record is stored randomly, irrespective of the order they come. So randomly you can able to store. Randomly it generates a address, binary address. Randomly you can able to store. Randomly you can able to update. Okay, for example, suppose a record key value this is the record key value. Okay, suppose R1, R2, R3 and so. Okay, up to suppose R30. The record key value, data records. These are record key values. These are the record key values. Then data blocks in memory. These are the data blocks. this is the data record, and this is the memory space. You can call data blocks in memory. These are the data blocks. In memory blocks. Okay. Suppose hash function accept these values R1, R2, R3. Okay. Suppose these are the values. Suppose I can call A, B, C, I, D, E. B, C, D, I, E, C, D, I, A, B. So these are partitions of memory. These are the binary. Suppose these are the binary addresses. So these are the binary addresses. Suppose these are the binary addresses. These are the key. Suppose R1 provides this address. R2 provides suppose this address. R3 provides suppose this address. Okay. R provides this address by using the hash function. So this is mapping. This is mapping with the record key value with the binary address of the memory. This is mapping between record key value with the memory address.